Superposition principle. Now, this principle basically says that if we have a solution of a non-homogeneous differential equation, let y1 be a solution of this equation, and y2 be a solution of the same equation but with a different right-hand side, then k1 y1 plus k2 y2 is a solution of the equation where the right hand side is k1 f1 plus k2 f2. So there are two things going on here. One is that if we have a solution to a differential equation of this form, then if we multiply the right hand side by some number k1 here, then this then if y1 is the solution of the original one, then k1 y1 is a solution of the new one. So this one is one of it, and the second is that the sum of two solutions is a solution of the equation where the right hand side is the sum of the two right hand sides. So it will become more clear once we look at some examples. So here we are given that y1 is equal to cos t is a solution of this differential equation, and y2 is equal to e to the 2t by 3 is a solution of the same equation where the right hand side, instead of being sine t, is now e to the 2t. Then part A says find a solution to y double prime minus y prime plus y is equal to 19 sine t. So obviously for this one, we just have to look at the first part of what's given. The second part will be used in later parts of the problem. Okay. So if you just have sine t, so the only difference between this given equation and this required equation is that the right hand side is multiplied by 19. So if cos t is a solution of the original one, then if you multiply the right hand side by 19, then 19 cos t will be a solution of the new equation. So we can just go to there. So we can just say (19 cos t) is a solution of this one. Okay, so let's enter this. 19 cos t. Okay, part B. Now we have something more going on. So now we are multiplying the original right-hand side of the first equation by 2. This was sine t, and we have 2 sine t. So this part of the solution will be multiplied by 2. So we'll have 2 cos t. And then we have a negative sign. So this just follows. If you have plus, you get plus. If you have minus, you get minus. And now we have 3e2t. So now over here, we have e to the 2t, and we are told that the solution for that is e to the 2t by 3. So now we are multiplying this right-hand side by 3. So instead of being e to the 2t, here we have 3e to the 2t. So you will multiply the solution also by 3. So this was the original solution, e2t by 3. You multiply this by 3, you just get e to the 2t. Right, this was the e2t by 3 was solution of this one. And when this gets multiplied by 3, you get this multiplied by 3. Now here, sine t is just sine t as it was here. So this solution cos t will just be undisturbed. And then we have a plus sign, so we get a plus sign. And now we have 15e2t. So this was e to the 2t, and its solution was e to the 2t by 3. So if this gets multiplied by 15, then the solution also gets multiplied by 15. So when you multiply e2t by 3 by 15, so if imagine multiplying this by 15, e to the 2t by 3, e power 2t by 3. So the 15 and 3 cancel out and you just get 5 e to the 2t. So you can just write 5 e to the 2t. Okay, so now let's look at here, a non-homogeneous equation, find a particular solution, find a general solution. Okay, so this is a particular solution, y prime t is equal to minus t. So here the idea is very similar to what I talked about at the beginning of section 4.4. Let's go back. Let me see. So was it 4.4? Okay. So 4.4 was about undetermined coefficients. Okay. So here, look at this number 3 thing. So we learned how to find a particular solution by undetermined coefficients. And then I mentioned briefly that the solution of the given equation is the sum of the homogeneous solution plus the particular solution. Homogeneous solution is the sum of the solution of the associated homogeneous equation. And we never used that in section 4.4, but now that's what they are asking us to do. They have given us the particular solution, so we don't have to do this work. All we have to do is to find the homogeneous solution, which we actually learned in the previous section, and then just add up the two. So let's go back to the problem. So the problem here is y double prime minus y prime is equal to t. So y double prime minus y prime is equal to t. So let's just copy this. So we do the business, which we have done quite a few times. So the associated homogeneous equation is just that thing is equal to 0. And the auxiliary equation, so r squared minus r is equal to 0. And this one factors r minus 1, r minus 1 is equal to 0. So r is equal to 0 and 1. And so we have real and distinct roots. So the general solution will be, let's try to copy the template. So here, let's copy it from 4.4. Okay, so the homogeneous solution in this case is this one. And R1 is 0. So we can just say copy C1 e to the 0t would just be C1, and e to the 1t, R2 is 1. Okay, so that's the general solution. And now the total solution, or the general solution, is y is equal to yh plus yp. Let's write that down. And that will be equal to YH is this one. Plus, and YP they gave us in the problem. So we didn't have to work for that. YP they gave us to be negative T. So here it was given. So the example was this. Given that a particular solution is negative T, so this question was find general solution. Okay, so now so this will be the answer, C1 plus C2 e to the t minus t. Now the reason why this problem is in this section of superposition principle, because this result that y is equal to yh plus yp is actually also superposition principle, because remember it has two parts. One is if you have a solution, then the multiple of that is a solution if you multiply. And here one part of superposition principle is that if you have a solution of two equations with different right-hand sides, then the sum of the solutions will be solution of the equation, same equation with the sum of the two right-hand sides. So remember, homogeneous solution is the solution when the right-hand side is 0, and therefore when you just add the particular solution to the homogeneous solution, you get the solution of the equation where the right-hand side is 0 plus the given right-hand side, or in other words, it's the solution of the given equation. So this result is also a special case of superposition principle. That's why this problem is in this section. So here it's C1 plus C2 e to the t minus t. C1. Okay, let's try some different constants. So C1, instead of C1, I'm writing A, B e to the t. Because I was just reading these directions, it seems that I'm allowed to use any constants. I don't have to just use C1 and C2. So I'm allowed to use any constants as long as I avoid these. And then minus t. Well, this looks right. C1 plus C2 e to the t minus t. C1 plus C2 e to the t minus t. So r is, let's just check the r square minus r minus 1, r is equal to 0, 1. E to the 0 t is just 1. So C1 and plus C2 e to the t. And then negative t was a particular solution. Let's see. Okay, so C2 e to the t. I don't see anything wrong. Well, let's just try our old constants then, C1 and C2. C subscript 1 plus C2 What's wrong? Yp plus C1 Y1 plus C2 Y2. I don't see anything wrong here. R square minus R. Oh, this is a Y and not a Y prime. So I'm solving an incorrect equation. Okay, so this is a Y. So if this was just a Y, this would be just a Y. So R will be plus minus 1. So R is equal to 1 and negative 1. So this will not be here. R is equal to 1 and negative 1. Okay, and so this one be C1 e to the negative t plus C2 e to the t. So this one will be C1 e to the negative t plus C2 e to the t. So C1 e to the negative t. Okay, so that C1 is actually C1 e to the negative. It doesn't matter. I wrote the negative solution first and positive second, doesn't matter. Okay, C2 e to the negative t, e power negative t. Okay.